Yeah, we are back. We are back. Sorry. Seems to be some problem. So we can. Why do we not get any points? Why do we? Why do we not get any points? So it's running. No, this can't. This shouldn't be. This shouldn't be. No, we're stuck. We're stuck in the loop. Actually, yes. Restart. Come on. Distance north south. So we're stuck in this loop for some reason. So if the horizontal position is smaller than the east, we're going from west to east. Horizontal vertical position is smaller than the south. Vertical position minus pixel in degrees word. Pixel in degrees word. What I don't understand is how is this possible? Okay, we try to make this a back for the x and y coordinates. So yeah, I know. We try to decrease the vertical position. And then if the horizontal is position is smaller than the east. I don't this was actually correct. We push onto the horizontal position. Now let's try to run it. And right. If we have something that we push to the temp go back, and then push the temp go back cleared so that there are no values, and then we temp go final points back push temp go back, so that we get some sort of two-dimensional array of values both in coordinates and we need to clone this. Right, now it should be running, but I hope. Yeah, it finished actually. So we're not crashing everything again. Problem is now that we the problem is that I am very poor at calculating percentages. This might sound bad, but I'm not percentage of completion. No. Percentage calculate. If we have the percentage. Oh boy. No, this is just embarrassing. We have the vertex coordinate. And we have the vertical position minus the south, the horizontal. That is the thing we're trying to get mapped to 0 to 1. If we divide this would get us the reverse. So basically need to reverse this. I'm not very fast in using Emacs, but I'm trying. Let's see what we get. Oops. See what we get now. This should 0. Okay, this actually looks fairly optimistic. We get the texture coordinate in horizontal is 0 and vertical is 0.27. This, I think these are the correct values that we are looking for. This is the first row where the vertical texture coordinate is all just this, but we are actually increasing in the value. Now what I'm just trying to get is what I'm trying to get is the length of which we are trying to get. What is the length? So if this is below 1201, we know that all of our methods have worked so far. That's non points 0 len and lat non points. Yeah, so 850 times 331. So this is actually what we are looking for. Now, the next step is to make a window and put the points, put the points into the window so that we can map the texture onto it and then reproject the texture. There might be some minor errors that we still have to work out, but I hope this is not so. Right. For each image, here's the thing, we need to maybe make separate windows, but this might, well, let's just make a window equals window app window new, and then just window handle events. So window, let's just make a window. So here we have the app window. We need we need to put it like this actually. At least the next frame time, which is where we use standard time instant and duration. Then we use gluten, which is, well, here's the problem, because we use Glium, this might be works. Glium gluten events loop. Use Glium just so that we can let's just try which errors we get. Yes, RC and FC are not defined. Use then wait, what? Oh, yeah, this is not actually where I wanted to have this. Standard cell F cell use standard RC because this can only be one. This can only be accessed from one thread, so it doesn't make any sense to make it multi-threaded. So yeah. Widget builder, yeah, we don't need a widget builder. Also, this should be a reference to self, so have the main loop let events loop self dot events loop clone. This is not events loops. This is stupid. Don't need to clone the events loop. Yeah, sorry. Now what? Oh, great. Now yeah. Well, let's just restart. This is much better. Ample app window. Let's yeah, 9. So handle events is actually main loop. I've just copied this from the lim examples so that we can. The problem is that this Gliom application regularly, I can show you what the problem is. If we go to Gliom, yeah, let's just clone this application so I can show what the problem is. This might take a while, but yeah, here we are. So if we look in the examples, let's just run the image example. Yeah, the image example. Come on. The problem is actually that the current version of this library has a very important fix that I have actually made to that if you use a previous version of this, you are likely to have seg faults if you compile it in release mode, and that's what this fixed. So the problem is that previously this library author decided to do a very pretty dumb thing. They updated the version of the window handling library to a newer version, which and the problem is if this will run, the problem is that you get very poor performance. I don't know how nobody has addressed this issue before, but I've made an issue and nobody has answered. But yeah, if you try look at this window. If you try to resize the window, look at how slow everything is lagging. And the reason why it's lagging is because it basically pulls every microsecond it pulls for events, and this is extremely wasteful. So the problem is that I do want to get updates from this, but I can't have a window that constantly pulls every microsecond for a new event. It's just it doesn't work. And if good. Oh well. Closing sometimes takes a while. But this is it's just horrible. And what I've noticed is that this lim application, this is actually a 2D layout library, and it doesn't have this issue for some reason. It doesn't have this issue where it's constantly polling. I think it's polling every second, which is somewhat okay, but it's still useless to just pull events every second. So I'm sorry. Basically what I'm trying to do is just to construct a window that will not consume all of the resources on the computer when it's just opened. So the Glium library has this concept of an event loop. Yeah, well, we actually need a window, and sometimes I think that, I could make my own library, but it's a bit cumbersome. So I need to basically look what the proper struct for this is. Glium gluten, let's say display, gluten window. Use gluten for the window and its associated. So yeah, we need to create a display. Window gluten display. This will actually construct the window. And now what we get is gluten display new. Let's just unwrap. Gluten display new. Window builder, yeah. They have this concept of a window builder where you can set attributes like the width, the height, if the display should be vsync, but this doesn't work with Vulkan and other APIs, so I don't really use it. Window builder equals, yeah, well, where do you have the window builder? Glium gluten window builder. Gluten window builder. Let's just use the default, I think default values, and then just pass in the window builder. Context builder is, so this is actually something that I really like, because they have separated the context from the window, which is, it's fairly, it's optimal, but context builder equals gluten context builder. And so actually this is Glium gluten, but this gets imported here, so it's better if you have this. And then we need the events loop. And this is actually a reference. So we need to make sure that the display and the events loop have a similar lifetime. So we need to store the events loop somewhere, and this is why we have this rcnew, refsurnew. This is a reference counted value, and this is a reference counted cell, which allows for mutable access. And you have to be a bit careful, because this can actually crash. So you have to be careful. Event. I don't think this is proper English. Events loop should be event loop, but whatever. Yeah. And this is just gluten events loop new, and it gets the display, so it knows which events loop needs the display. Events loop new grid proxy. No, don't we need a, oh yeah, we actually have this stored in the display, so this should work. So events loop next frame time is instance now, so the current time is the instant. I think this is used for timing the redraw of the window, but I'm not particularly sure. Again, if we would just use the operating system native events loop that already exists, we wouldn't have to deal with all of this timing. It's just, I don't really understand it. And the display. Right. Let's see. Gluten display. You could not find display. Okay. Oh yeah, because it's somewhere in a backend. One thing I wanted to say, I have tried once to get a headless display, but it's not really possible, because what you need to do is you basically assume that the computer you're running on has a special window. Oh yeah. Has a off-screen driver of OpenGL, and this is not really something that's always the case. So the best way to get a display up and running without having it display on the user is to just set in this window builder, set that you want the display to be hidden. So this will basically create a hidden window, a window which you don't see, but it's there, and it just works. And well, this is what we will try to do in the end, but yeah, reference to events loop. Has no field display. Self dot handle window event. Okay, now we are here. Loop self dot poll events, self dot handle window event. Again, this is something that I've just copied from this handle window event. Self dot no. Yeah, this is for event handling, handle window event. You don't actually need this. But now, if no, UI draw if needed. We don't have this, but we basically need to redraw the screen here. Redrawing the screen is, yeah, it's not very nice. Self dot next frame time. Okay. If self UI dot needs redraw, you can basically render frame ready. This is not something that we need right now, but for event, in events have handle window event. Yeah, I think we should just copy this. I mean, it's MIT license, so I don't think there are any problems. So we don't need this, but we may react to the window resized event, otherwise we won't actually be able to resize the window. On the other hand, since the display will run headless in the end, this might not even be necessary to actually handle events. Yeah, I don't have the debug thing going on. So if self UI should close, yeah, self.ui that should close. Let's just yeah, the self that should close. Yeah, this is basically the problem with a bit of object-oriented design, but I get what he's trying to do. Basically, we need to say if self-handle window. I once the usual way I go about handling events is that I have some sort of window state which contains the keyboard state and the mouse state. So, and the first thing I do in the event loop is to update this state to match the latest state that we have. And then later on, all other applications can go in and read this state, but they don't change it in any way. So it's fairly safe, it's thread safe and whatnot. But let's just try if we can get any window on this screen. No, let's just comment this out and just run it for all eternity and then kill it via the terminal. This is probably a way. So I have to handle events. So handle events, handle window event. No, we don't have this method. Handle events. Does this work? Let's window. Not closure construction here. Cannot build save.events loop or mute. Save.events loop. Closure construction. Oh boy. Borrow. Save.handle window events. Do we actually need this? We don't even need the access to the window, we just need the event. So what we can try to do is to just use do this. Yeah. And the same thing with oh yeah, we actually need to build and compile. Uh, and if this works, it should get a window on the screen, which, yeah. So here's our window, and it doesn't have this. It still has this resizing bug. See, it still has this resizing bug, and I don't know how to deal with this, but and this is a problem, but it's not a huge problem. It's not a huge problem, really, because we don't want to resize the windows. In this case, it's fine. If you're programming a game or an application, which I'm doing, you don't want this. You don't. Yeah, and since we run forever, we just need to kill all image, no, SRTM, the image, yeah, which should kill this, but it doesn't. Why not? Yeah, now it's killed. And that's the problem. What you saw was not actually any lag, but the problem is that these events get buffered, and this poll events just has to run on every single event that we get, and we get a lot of events. The earlier way allowed us to ignore some events, but for some reason they decided to completely ignore the fact that we want to ignore these events. So yeah, that's where we are. Yeah. Sorry, I have to drink now. Right. So what we will try to do is just to clear the screen. Let's just clear the screen. Where is the screen? Right, the screen maybe. Clear service. Yeah, we need to main loop, and then we need to draw to the screen. And in order to do this, we need to have access to the need to have a frame, which is a Gliom frame element, I think. In order to get a frame, we need a frame, and then we need to. We shouldn't finish here. We should. Let's just remove this. This is unnecessary for now. Redraw screen here. At frame equals self display dot. We have this display, and in order to get a frame from the display, we need to rebuild draw. Right. We need to draw, which gives us a frame. A frame is basically one single frame that we put on the display, and then we need to clean it up with frame.finish. And between these two things we can draw everything that we want. This will notice the string even as vsync is enabled. Frame will be resized. So this handles the resizing. And on the frame we can actually clear. Don't want to clear, we can split from frame buffer, split from clear color, clear color, clear color and depth. This is what we want. Oh boy. Clear the depth. So we will say red 1.0, 0.0, 0.0 and 0.0. Well, let's try. Clear on frame, yeah. Oh boy, I hope the new module system should fix this, but it's just it's a bit horrible. We need to basically import the frame before we use it, so use clear on frame, and then we can just say that it's the frame. Clear color and depth. Yeah, and this is something that I don't really get, but why do traits need to be imported in order to be used? I do not know. Maybe it's some compiler thing. This is actually, yeah, let mute frame. This frame is being drawn to, so it changes state, so it's mutable. Yeah. Now this should give us a red image, basically. There are a lot of people in the chat. Yeah. Red window. We have a red window, everybody. Yeah, please. Oh. No. Oh. Kill all SRTM image. So. And I think this is a good time to say but if you want to follow along, I've just put this on GitHub. Oh, wait. So if you want to follow along, this is the repository. The goal is to, the goal is to reproject the image that we got earlier. So for those who are new to the chat, this is the image that we currently can load from a Hive map. And the goal is to make some sort of shading and lighting and all sorts of stuff, which is why we need OpenGL to reproject basically the whole image. So what we did earlier was to generate points along these pixels. So if I can, do I actually have, no. And what we have is a region of this image, and what we're trying to do is to map this region onto the screen so that we can later on read back the frame buffer and use it for blurring. Blurring is basically when you zoom in and you have this slight blur effect going on. This is basically what we want to achieve. And I've done blurring on the no on the CPU side, which is yeah, which is here, which is a CPU library to you make a Gaussian blur. However, we also need to reproject the image, so UTM yeah, we need to try to English. The current projection. I'm not sure about the current projection. The current way that we are doing this sort of stuff is this is where our coordinates are currently on this ellipsoid. And so what we're trying to do is get from the ellipsoid to some sort of XY thing. And I've done all of this talking just to show you. Oh boy. Yeah, this is going to take. Anyway, next thing is to draw to the screen. So self draw reference mute frame. Self draw frame reference. No, we don't actually need a mutable reference, but we just need a reference. I think maybe this. So here is where we do all the drawing. And for now we need vertices. We need indices, and we need a texture. So the best way to do this sort of stuff is just to look at the examples. This is easier if I do it like this. So I have the image. Come on. This is what we did. We created the event loop, then we had the window, context, this. So this image, this is what we will. Oh, we also need the image library, which is, yeah, we already have it. We already have the image library. OpenGL texture equals da da da. Now we need basically this in our renderer. I would put it in the renderer because it's so position and texture coordinates. And then we also need to make some sort of shaders. No, you should not, don't copy the shaders. I don't know how to make folders inside of Emacs, but I also don't know why he constantly makes symlinks to the other files. It doesn't make sense. So what we make here is a, let's just call it main.word. And just copy it and call it main.word. We will need several of these for blurring the image, but right now we only need main.vert. This is a GLSL shader, which is fairly simple to understand. There are several types of shaders. There's vertex shader, fragment shader, tessellation shader, tessellation control shader, and compute shader. So since we're trying to get a lot of people who can use this application, we try to limit the version to 130. I think version 130 is the most recent, but the oldest version that we can still use for this shader, because all that we need is a vertex and a fragment shader, and the rest is done by just calculating some stuff. I think it's always when Emacs crashes it uses these links, but let's just vertex shader. He uses, okay, this is a, well, this is some form of magic where basically you tell the program which the program is a gluten specific program struct which chooses the version of the shader at runtime. So you can have multiple shaders and then have fallbacks for different shaders, but I really don't need this. So yeah, you have to be a bit careful with this. Back to coordinate and in back to text chords. This is the same layout that we will use, because this position will be the position that we calculated in the loop, and then the text coordinates will be the appropriate texture coordinates. And this way we can actually map this image onto the screen, and then later on in a later stream we will use various cool blurring functions and whatnot. But this will be done in a different stream, because I'm trying to get the image on the screen, and then we will end this stream, because it's really a bit tiring now. So, and then the GL. Now what we also need in order to do the reprojection is to know in float window with UTM and in float. I can actually copy this from the old shader that I already have. There's no source, oops, shaders, no graphics shaders. Where's the UTM area? So this is actually something that I've done. I've ported the UTM reprojection to the GPU, but the problem with this is that it doesn't reliably work. So yeah, that's really a large problem, because basically on one computer you can get a beautiful reprojection, and on the next computer you get a blank image. So something to keep in mind. We don't need this. We don't need this. dot lat equals these coordinates are already converted, so and since we don't have any x and y, but since x, y, z and w are the first, this is basically the first component of this vector, and this is the second component. So, and delta east west and delta north south. And then what we do is we simply calculate the position in clip space on the screen. So so this is the so this is the what we are trying to get. We try to get something from minus 1.0 to 1.0 1.0. That's why we add this minus 1.0. I'm not sure how I came up with this, but it sort of works. Z index is not important. This was important when you do layering, you have a depth buffer, but in this case we don't. So yeah, let me just, and the v-tex coordinates equal the this is delta east west, delta east west, delta east west, and this will be in meter, delta north south meter. But we have to do the reprojection of the points on the CPU side because it won't work otherwise, probably. Delta north south meter, y minus, we also need in float west, in float south. So this is vtex chords equals tex chords, and then the fragment shader FUTM. This is just the most simple fragment shader that you can basically get. So shaders. Uniform back for color fragment. We're trying to no, what we actually need to do is to, let's just say it's always red, or at least 0.0, 1.0, 0.0, 0.0. Is it 1.0? This is something that I often get confused, so this just should be a half transparent blue rectangle. So here we have our vertex. Vertex fragment. We have the conversion library. We have the main window, main function. we have the window. So the way that we would go about making the vertex shader, yeah, we need to basically say, okay, in order to, yeah, I have loaded this. In order to use the vertex shader, we have to basically import it into the binary. This is the best case, so that we don't get, we won't load the shader from an external file, but we'll just include it at compile time, which is the best way to go about this. So, const vert UTM shader reference. You don't have to do the static anymore, but I still do it. Include dot slash shader slash, what did I call this shader? Shaders main dot frac, main dot vert. Right. Now what we need to do is to say, okay, when we create the window, we should put this in the window unless we have some reason to do otherwise. So when we start up the window, we basically compile all the shaders, and we should use a const UTM shader ID Now what we do is we make a hash map. This does work for simple cases, but if you want like the ultimate performance, this is not a good way to go about it. Maybe it is, I don't know. So we map this to a program. So now we need to compile the shaders. And this is just a, we need to use standard collections hash map. Then we compile our UTM program. Equals program from, again, these are abstractions around the OpenGL stuff, so it's not, you won't be learning any OpenGL specific stuff, but it's, the problem is I don't really like to program OpenGL. It's something that I have done and I don't like it, and it should just be somewhere in a library, and that's it. So what we try to do, program from source. I think this is program from source. Program. Yes, from source. So we need a facade. The facade is going to be our display where we upload the vertex shader, fragment shader, geometry shader. We don't have a geometry shader. Well, we could do this reprojection in the geometry shader, but yeah, no, we won't. And then our vertex shader is a I would like to have this in the renderer still. Shader ID UTM code run. Oh. So program from source, we need the renderer vert UTM shader. I don't have auto completion right now, but I'm trying to set it up for the next stream. And we don't have a geometry shader, so we just can pass none. Oh yeah, we need the display. We need the window builder new. We need to build the display before we can use build our shaders. Oh. And here we pass in a reference to the display. And this should actually work. Right. Let's hope for the best. Yes, build, please. Oh yeah. Oh boy. Use renderer. Yeah. We need to, if we say this probably going to be is private, so we need to app window has no shaders. UTM shader ID, so we need to run. This should be public, but I still like to keep it in the renderer because it doesn't have actually anything to do with the window. So let's try and build shaders, picked it. Oh yeah, we need to unwrap this, so there could be something going wrong with the shader build process, which is good because then we have catch this error at compile time. Yeah. Dot unwrap and save to draw that frame dot finish dot unwrap. This usually never fails, so we can just use unwrap to just ignore the error and just crash if it doesn't work. Variable does not need to be mutable, okay. What? I don't even use this txt variable, or do I? No. We don't even use this. Reader, we don't need the reader to be mutable, so we don't need the count to be mutable. Yeah, we don't even need the count. Oh boy, undefined variable color. Yeah, so this is what you get when you just try to write the shader. I don't know if there's a better way to write shaders, but have them somehow checked at compile time. If you write Vulkan shaders and you use the Vulkan shaders are basically the same as OpenGL shaders, but if you use yeah, this is a library for Vulkan, so if you use Vulkan as an API, I highly recommend to use this library. But if you use this library, you can actually see that in the in the example for, let's say, the triangle. This is the most easy one. You can have a shader. Where's the shader? Shader. Oh boy, shader. Where is the shader? Yeah, here's the shader. You can say that it's a vertex shader, and you can also specify a path here. So this way you can get the errors directly at the compile time, and you don't need to run the application, which is nice. But yeah, the issue is that this color is basically undefined. So out color vec for color. I think that's the problem. Because OpenGL implicit cast, boy. Implicit cast from float to vec 4. Wow. This? If it's not this, then yeah. So there we are again, but now we have a shader. Right. Progress. So oh boy. Come on. That we have done this. Just wanted to, yeah. So what we have now is we have this image. Right. I hope I can, no. Just use red. So we're basically looking at like this region, and we have the individual pixels as well as the individual texture coordinates for these pixels, And now what we need to do is we need to upload these vertices to the GPU, and since we have then reprojected the pixels, which will result in maybe something like this in the final result, then we need to use a frame buffer, render everything into the frame buffer, put the frame buffer onto a texture, and read the texture back to the actual image that we done, and then we're basically done. So this is the plan. What we have right now is just the shader to display this sort of stuff. So right. So we have now the window main loop. Window main loop. Yeah, we need to draw the thing. Here's the problem. Window main loop. Basically, what we want to do is to. Problem is that we need to create a vertex buffer from these points. And let's just. I will maybe clean this up. Not live, because cleanup is very boring. So I don't want to do this, but basically. Points is a reference. Now we can actually consume the memory because we don't need it anymore later. And this will return a Gleon vertex buffer of renderer vertex. So the type that is returned. So this is one of the cool things where traits are really useful. Then we basically take the result that's coming from. No, it's actually not. Yeah, I might. We take the renderer. So this vertex, if you I forgot to use the implement. The Gleon crate library has a macro, and this macro is called implement vertex. What this implement vertex does is it tells OpenGL the offsets and the structure definition of our vertex, so that we can finally use so we can use this vertex and push it onto the GPU. Implement vertex. There's also a derive thing. I think you can derive Gleon vertex or something, but it's just vertex, and then we want the position to be the position and text chords to be the text chords. And these will be actually the reason I've named the position. These will be the names in the actual shaders, so that so that OpenGL knows that these positions are actually our positions, if that makes sense somehow. Oh. Yeah. Coordinate. I should name it coordinate. And this F32 tool will be mapped to a vec tool in OpenGL. And this is what this macro basically does. This whole thing is very, very complicated. But if you wouldn't do this, what you would end up with, I can show you that I have done regular OpenGL programming in, yeah, what you have to do in, let's say, C++. You would basically have this, yeah, and then have oh, line, no, that's just, yeah, you'd have some form of function, set GL shader source, GL compile shader, and check the GL compile status, GL attach shader, GL get proven, delete shader, yeah, you don't need the shader anymore, and then renderer. Basically, you need to, this is what we have done in order to, we also need to enable the depth test, because that's something we haven't done yet, but, you know, compile shaders, compile basic, and bind at location. This is what this does, GL bind at replication. And this is basically contained inside of this macro, which saves a lot of typing, so I use it. Alright. So what we need to do now is to make actual vertices, because right now we only have, yeah, we only have this where's our, we only have this vec F32 stuff, and we need to I have opened the so what we need to do is to have a function that can generate make vertex buffer, and that takes in the output from the previous function, so that we don't have everything in one function. Points reference to, no, we don't. Takes a 2D array of points, that's coordinates and texture coordinates, and builds a vertex buffer. So we don't need inits. Yes, we do need inits. Inits become important, but for now we only need to I am in the render class, right? But, oh. Right. we need to return the vertex buffer of type vertex, and this vertex has to implement the vertex trait. So this is what this vertex basically does. This macro basically does. So it's some form of type safety. Alright, now this is sort of the last step, because this is fairly easy. Here we have the coordinate, here we have the texture coordinate, and all we need to do is to make for row in points. Do we actually have no for row in points, for point in row, and point takes coordinate, and just let's try to make it a bit better Rust. So we can just say points iter into iter map row dot collect. We actually need to have a flat map, because otherwise this won't work. Flat map the row, and then we want to row dot into iter map, and then we have the chord and the text chord, and then we collect them into vertices, and all we need to do now is to emit a vertex with the coordinate, coordinate chord equals chord 0, chord 1. I think you can match tuples and text chords directly, but I'm not sure. So if we have a two value tuple, you can directly match put it inside a two tuple array as long as the values are the same. But I hope that Rust is smart enough to figure this out. Yeah, let's just right, and then this should work. Yeah, Gliam. The reason I've separated these two functions is because later on, if we might upgrade to Vulkan does not have the regular vertex buffer, because in OpenGL you bind it to a display. In Vulkan you bind it, I think, to a device, and so this function would be useless. So if we would use Vulkan, we could just not have this function. So this is why we can actually inline this, but won't make any different text chords. Yeah. Gliom vertex buffer, use Gliom then we can just say oh yeah, we need to we need to let vertices, yeah, I forgot this. We need to actually have a reference to the display, reference mode display. So that we can build, and this step will upload the vertices. I think this will upload the vertices, I'm not quite sure. But basically we need to upload the vertices and indices, where the best way to do this is to actually look it up. So let's go and see if no, yeah, examples, and then let's just use the teapot. Camera, no, we don't. There's too much going on. Vertex buffer, yeah, we program uniforms params. Right, this is the function that we need in the window function. So here, this is what we need. We don't want indices for now. Later on we will use indices, but right now we don't need any indices. So the vertex buffer problem is this function runs on every loop, so the best way to go about this would be to have some sort of vertex buffer, but then we would need to start in the window, we would need to store the vertices inside the window, and you know, this is not something that you should do. And it doesn't actually hurt us much to upload the vertices on each frame. Maybe it will hurt us, but you know, for now this function is fairly useless. Here's where you set the type. So trying as list is so this is what we're trying to do. My voice is not very good. I've talked for about 2 hours now. I think if we just get the program to compile and to actually run and to upload some vertices, no matter how shit it may look, we will just end the stream then, because it, yeah. Program. So this is why I put the program. We only compile the program once, but then we can just use this hash map to get the program again. Draw. The problem comes with borrowing. We cannot. We actually need to have the shaders so that this function is independent of itself, because we probably have borrowed, we have this mute self already borrowed, so we cannot borrow self again, and this is something that you have to be aware. We cannot borrow it because we currently mutate the events loop. but we don't, we cannot redraw the screen when we borrow ourselves again. So I can't just use reference self here, because this wouldn't work. So what I need to do is I need to have a reference to a hash map reference to this, and then we can use shaders get then we can get it by this ID. I'm sorry, I'm sort of all over the place right now, but I hope this makes sense. And then we can pass we don't actually need this because this is already a reference, but on that. No indices, uniforms, we will not have any uniforms, so sorry, no, 1 0 2 so we will just use the empty uniforms. Uniform values are useful for when you want to push something onto the GPU, but you don't want to, it's not a lot of data, so it's just one value or something. Then you can use uniforms and push them like a color, what you want this to be shaded. And here we can just use default because these parameters don't they implement the default trait, so we can use the default implementation of the uniforms, which is just so no uniforms at all. So what we need to do is we need to have a mutable reference to a display. So we need to, I don't think we can get around the data being stored inside the app window, because basically the app window is like a superstruct that contains all other elements. And I have not found a way to do this in a more functional programming way, but well. And so we need to basically have the data, which is a we need to have a vertex buffer of type renderer vertex, and then we need to have a vertex buffer, and here we need to have the window new. This is not a good design, but oh well. And we can call let vertex buffer equals renderer make vertex buffer. Mutable reference to no, we don't actually need a mutable reference, we just need a normal reference. Then instead of using this in the main function, we generate the points inside here. reference to left, display lat run points. And then we should use the vertex buffer here. Then self.draw. Yeah, you need to redraw the screen, but this time we need to give a, because the Rust compiler can actually see that we are only borrowing this events loop. We should maybe put the events loop outside of the current renderer, but this is something for a later day. So reference to self.shaders, and we also need a reference to self.data. This will be get uploaded every frame, I think. And this is bad. This is bad because if you already have uploaded the data, but anyway, for normal design right now, it's perfectly okay. Self.draw, self.date, no, vertex buffer. Right. So we also need to use the vertex buffer is a reference to a vertex buffer of type renderer vertex. Right. So this should work. We reference self.vertex buffer. We don't duplicate any data. So program shader.get render vertex buffer is just, we don't actually need this program because this is already a reference, so we don't need to do a double reference. Drawing and events, redraw the screen. Yeah. Just so I know what we are doing. So the next is actually to open the renderer again, use the display points and returns a vertex buffer. So I think the vertex buffer is Gliom vertex buffer new reference display reference shape. Reference shape is a vec of vertex. Yeah. Right, exactly. No indices. Yeah. And we can actually, if you don't put a return statement inside a function, I don't know how many of you are familiar with Rust, but if you don't use a return statement and you leave off this extra semicolon, then it will automatically return the value that, so you don't need any intermediate values. And shape in this case is just vertices. And after we can throw the vertices away because we can actually throw them away, I think. I'm working on my TH sound. So let's build, and if this builds we will end the stream because it's, yeah. So we will try to build, and it doesn't build, so we don't end the stream. So, oh boy, should we just use the when we generate points? Yeah, let's make the window new final data. Generate points. This should be maybe in a different function, but well, yeah, I do not see any way around this. Image bbox, generate points, image bbox. So, what do we do now? We'll put this again in the main function, and then we can just this is completely bad design on my part, but yeah, no, we don't, because technically the app window should have nothing to do with generating the points, but hey, now we need to use this. Back. Points, we have points. Then we use the make vertex buffer. And then we use just the points that we got. Target.draw. Frame.draw. When your vertex is private, okay. We need to have a public struct. Public coordinates and public vertex by oh no, not this again. It's not implemented for reference display. Do we just need the display? Maybe. Vertices. Back. Vertex. Sometimes the compiler is too stupid to actually see that we are trying to make a vec of vertex, but I hope this flat map. No, just come on. Collect. No, I don't. vertex buffer, does not have this field, vertex buffer. Yeah, I call it data. No field, vertex buffer to itself. Oh yeah. Well, that should just be flat map. This is why I don't really like Rust iterators, because flat map, technically, what we're doing here is we're mapping the row to something. It's just a for loop basically, but for loop we are returning vertices, then we are collecting them into a vec of vertex, right? And now what this flat map should do, it should take all of these vec of vertex and merge them together into another vec of vertex. But somehow, yeah, now it works. See, sometimes you have to do type annotations to make this work. Sometimes, but other times you're okay. You're completely fine without them. Oh boy. Use of moved value lat long points. Yeah. We cannot because we have moved the lat long points into the app window, and now we cannot get them back. So what we need to do is to say, okay, we just print it here. So we need a reference mutable to frame. Right. If this runs and it doesn't crash, then I will end the stream, because it's been 3 hours now. Oh, it crashed. So program attribute. Oh yeah, I forgot to do any uniform bindings. Basically, we cannot have empty uniforms, because we need to have uniforms, because I told OpenGL so in the shader. So these uniform, this is actually uniform. I don't know why I made this an in variable, but uniform. A uniform is basically something that doesn't change per vertex. There's also a varying and an attribute, but the problem is that I've always used uniforms because I didn't know what these other types were. Possibly if you're doing performance optimization, you can dive in and see what all of these types do, but I don't really care. So we need uniforms basically. And since we're not doing we need to, yeah. No, don't save. So, we need uniforms. I'm currently doing this copying because Emacs has a stupid bug where, well, it's not a bug, but you cannot copy between windows, and somehow it works if you copy it out and then back in. It's a bit complicated. And this doesn't seem to work very well. But Now the way to get uniforms is again via macros. If you're doing this in, let's say, C++, you could get your uniform location, uniform location. Do you get location? Because all of these uniforms have an implicit location. If you are programming for Vulkan, you actually need to say what locations these are. So this would be how do you do locations? Location. How do you do location? Do you link program? Do you use program? Location. Oh. Uniform. Oh, where is the actual? We can actually git branch git check out head. Right. Now this should graphics shaders. If you use Vulkan, you need to do sampler 2D text uniform. Where do we actually have the... Sorry, just wanted to say the... Yeah, shaders. Right, you do something like this, layout location equals 0. You have to do this. In OpenGL, in older OpenGL, you don't have to do this. But you have to actually say, layout set and layout binding. Set is specific to Vulkan, but and you have to do it like this, which I personally find stupid, but it can be more efficient in larger shaders, you know. Anyway, we're trying to get uniforms working. And the uniforms, if you go to the Gliom examples, he has made a bunch of tutorials, and these tutorials are very, very good. These tutorials basically teach you how to get a window up and running. See, here we have the vertices, we have the vector of with the vertices, and build the vertex buffer and program from source. Uniform. Right. This is actually again a macro. One of the confusing things about Rust macros is that you don't have to use, so if I would use these braces or these braces, it does not matter. So in this first field, it's what you want to have, delta, come on, delta east first meter. And let's just say this is 50 or something. And just let's duplicate this and delta let's just set this to 50. I will explain how we will calculate these values and why we need them. Well, I can explain why we need these values. So that's probably the last thing I'll do before I end the stream. So come on. So what we have right now is something that's like this. Here we have minus 1.0 and here we have 1.0 and here is 0.0, 0.0. I'm sorry, I'm drawing this with the mouse. I'm not the best artist. So what we are trying to do here is, yeah, does this actually work? No. So what we have is we have the x, let's say this loop, this runs for each vertex that we have, and we're trying to get points like this, right? We're trying to get points like this so that we can map this texture onto these coordinates and then have it on the display. So I know what I did. So we start at minus 1.0. We start here, both in x and in y. And then we have the x coordinate minus the west. So this difference, I need better color. So this difference, and then we have the width of the window. So this is what the window. So this is the full window, and then we basically calculate the percentage and add it to this minus 1.0. That's the whole thing. Because if these now what we need is the window, and this will be required in meter. So what we need to do is we need to first see where are we right now here in this. We need these 2 points and then project them into the UTM coordinate space. So, and this is basically the x, and that's the whole magic right there. And this is why we need this delta east-west meter and this west and south. This west and south will stay the same, so this is basically this point here, so that we can calculate this offset, right? So west, these are garbage values right now, just whatever, just so that it, oops. Yeah, just let me out. It will crash. It will crash, but we want to have a reference to the, yeah. No, it should crash, it should crash. Oh, come on. Oh no, he didn't delete my... Son of a... He did not delete my... Rest 50... 6.0, so... 6.0. These are just example values. And then we need to again kill, because I haven't I can't close this window right now, so I always have to use kill all. Right. This should close it, yeah. So what we have right now is something working, and we will do the texture sampling in a later video, but for right now we only need this to work, and I'm pretty much tired because I've streamed now for roughly 3 hours, and I hope it was fun. I don't know when I will do the next stream. Maybe tomorrow at the same time, roughly from 3 p.m. Right now it's 7 p.m. Maybe 3 to 6 p.m. So what we have done today is basically we have calculated these points and we upload them to the GPU. They don't display yet because the calculations here is wrong, but we have uploaded them, and then when we upload them, we can map the texture, this region, we can map this and then do blurring and transformation. Well, we do the transformation beforehand, but yeah. So I hope you all enjoyed the stream. If you have questions, please just put them in the chat and I will try to answer them. Right? If you don't, just this is pretty much it, what I wanted to achieve for today. Right. I hope the chat is working. I think. Right, if there are no questions, then I will end this stream, and I hope you enjoyed, and well, hope you check back later. Thanks everybody. Right.